Welcome you all in the lecture number 12 of Engineering Mathematics MTL 1025. Okay, in this lecture we will discuss about the singular point, classification of the singular point, double point and classification of the double point and related examples. Okay. Singular point and multiple point we already discussed in our previous lecture, but let us review of singular point and multiple point. A singular point, suppose y is equal to fx is a curve, y is equal to f of x, it is a curve and this curve is this, right? Then point P, if we draw the tangent at point P and we take a small neighborhood of the point P on the curve, right? Then see this arc, say the name of the arc is AB. Then the arc APB is a small neighborhood of point P. Okay. If this small neighborhood lies one side of the tangent, then this type of point P, this point P is not singular. Right? It's not singular. But if we take, suppose this is the curve and this is the point, if we draw the tangent, then our tangent is drawn by the green line, this line. This is the tangent at the point P, and if we take the small neighborhood, right, then one portion of curve lies upward direction and other portion of the curve lies in downward. Okay, then such point is known as singular point. This type of point is known as singular point, right? Then what is the definition? A point P on the curve at which curve exhibit an extraordinary behavior, right? It's called singular point. It is two type, point of inflection and multiple point. Point of inflection we already discussed that for a given curve y is equal to fx, the point of inflection P, that is d2y by dx2 at point P is equal to 0 and d3y by dx3 at point P does not equal to 0, right? Then the point P is known as point of inflection. Okay. Next, multiple point. A point on the curve. See, what is multiple point? First condition is that this point lies on the curve. This point lies on the curve. A point on the curve through which more than two branches of the curve, right? More than one branches of the curve passes is called multiple point, right? This is the one type of singular point, and a multiple point is double point, triple point, or rth order multiple point if at a point two or more than two branches of the curve passes. This is two branch of the curve, then point P is known as double point. Okay, in our syllabus only double point is written, but see, double point is kind of multiple point if at a point P more than one branches of the curve passes, then this point is known as multiple point, right? It is the one type of singular point, and a point on the curve through which two branches are passes, then this point is known as double point. If more than two branches of the curve passes, then it is known as multiple point. If r branches of the curve passes, then it is multiple point of rth order. Okay. What is double point? A point P on the curve. Remember that this point always lies on the curve. Point P is double point. The first condition is that lies on the curve. This point lies on the curve. Later on we will see this in the example. And if at that point P two branches of the curve passes, then this is known as double point. If three branches of the curve passes, then it is known as triple point. What is the classification of the double point? Double point are many kind, right? This is double point is also known as node, cusp, conjugate point. When we say it is node, when we say it is cusp, when we say it is conjugate point, let us see by the example and diagram. A double point on the curve is called node. First, what is node? Node is a kind of double point. A double point on the curve is called node if two tangent at the double point are real and distinct, right? Suppose this point P, two tangent are passes. Number one this tangent and number two this tangent. Okay. These two tangent are real and distinct, right? These two tangent are real and distinct. Then this type of point is known as node. In this example, P is the node point. Okay. See what is cusp. If at the point, see this Q in this diagram and in this diagram, this Q is cusp, right? But what is cusp? If at the point, say for example Q, two tangent are passes, right? This is the tangent, but this tangent is not one tangent, it is two tangent. Two tangent are passes, but they are coincide with each other. Means one tangent is the other tangent also passes from the same point Q. Two tangent passes through Q and they are coincide. Then this Q is known as cusp. And a double point is said to be curve. A double point on the curve is called conjugate point if the point lies on the curve, but there is no immediate neighbor which lies on the curve, right? That is, no real tangent to the two branches of the curve passing through that point. Suppose this is the point R, right? Okay. This curve, say curve is C, right? Then curve C union with point R. This is the whole curve, right? Not only C, this point is also included in the curve. But at R, right, note real tangent of the two branches of the curve passing through this point R. Such point is known as conjugate point, right? It is something like the isolate. Okay. How we check? By the given equation of curve that this point is node, this point is curve, this point is isolate or conjugate point, right? For given curve, suppose for the given curve fxy equal to 0. For this fxy is equal to 0, you have to evaluate first and second order derivative, that is fx, right? Fx, you know what is fx, dou f by dou x, right? Fy fxx, fxy and fyy. Okay, what is fxx? Dou 2f upon dou x2. Okay, then what is singular point? A singular point can be obtained by solving this equation, fx equal to 0 and fy equal to 0. Solve these two equations, you got singular point, right? Say singular point is x1, y1. Then what is the classification of this point? This is either node or cusp or isolated point. Okay, see, this x1, y1 is either node or cusp or isolated point. These are the classification of double point. Okay, these are the classification of double point. Okay, then this x1, y1 lies on the curve. First condition, this satisfy the curve, means f of x1, y1 equal to 0. First condition is that. And second condition is that if f of xy minus fxx, f of yy at the point x1, y1 is greater than 0, then this is known as node. If this is equal to 0, then it is cusp. If it is less than 0, then it is isolated point or conjugate point. Okay. Now see the example. Find the position and nature of the double point of the curve this x square into x minus y plus y square. What is fxy? Fxy is this x cube x square y plus y square. Okay. What is fx? 3x square minus 2xy. What is fy? Minus x square plus 2y. What is fxx? 6x minus 2y. fxy, fyy. Okay. Then the singular point can be obtained by solving these two equations. Fx equal to 0, fy equal to. If fx equal to 0 and fy equal to 0, after solving this, we got this x equal to 0 and x equal to 3. And x equal to 0 and x equal to 3 putting in this equation, right? Then we got y is equal to 0 and y is equal to 9 by 2. Then 0, 0 and 3, 9 by 2. These are the singular point. But check whether these 2 points lie on the curve. First see what is f of 0, 0. F of 0, 0 is obviously 0. It means point 0, 0 lies on the curve. Okay. This point 0, 0 lies on the curve. Second, 3 and 9 by 2. See, 3 cube minus 3 square into y, that is 9 by 2, plus 9 by 2 square, that is 27 minus 3 square into 3 square, that is 81 by 2 plus 81 by 4, and this is equal to 27 into 4 minus 81 into 2 plus 81 divided by 4. Okay. See, this thing is not equal to 0. This is not equal to 0. It means this point 3 and 9 by 2 does not lie on the curve. Right? This does not lie on the curve. Then we will not going to check this point as a double point or not. Okay. We only focus on 0, 0. Since 0, 0 lies on the curve and this point does not lie on the curve. 0, 0. What is f of 0, 0, 0? Means 0, 0 is the double point. Okay. 3 and 9 by 2. F of 3 and 9 by 2 does not equal to 0. Hence this is not a double point. So see fxy minus fx x f of y into fyy. What is fxy? That is 2x. minus 2x square, and fxx 6x minus 2y, fyy 2. Now putting in this x equal to 0 and y equal to 0 and solve this, we got this, right? This is equal to 0. Then if this is equal to 0, then what is 0 0? 0 0 is a cusp. See another, fxy is equal to this equation. Okay, now evaluate all the term fx, fy, fxx, fxy, fyy, fx equal to 0 and fy equal to 0. Solving these two, fx equal to 0 and this thing is 0, fy equal to 0, this 0, x is equal to 1 by 3, x equal to minus 1 and y equal to 2. Point is that 1 by 3 and 2 minus 1 and 2. Check whether these 2 points are lies on the curve. F of 1 by 3 and 2. This is not equal to 0. Hence this point is not lies on the curve. So this is not double point. Okay. And what about the f of minus 1 and 2? This is equal to 0. Right. We already told you, first you check whether this point is lies on the curve or not. If not lies on the curve, then leave it. It is not a double point. If this point satisfies the equation of the curve or this point lies on the curve, then it is double point. But which kind of double point, you have to verify it. Then f of minus 1 and 2 is equal to 0. It means minus 1 and 2 is the double point. Now consider fxy square minus fxx fyy. What is fxy? 0. What is fxx? This. fyy 2. Right? This is 4 minus 12x. And putting here, what is x? X is equal to minus 1. And what is 2? Oh, sorry, y is equal to 2. Then this is equal to 4 minus 12 into minus 1, that is 12, means 16, which is greater than 0. Means this point is a node. Okay. See another example. X cube plus y cube minus 3axy. This curve we already drawn in our previous lecture. What is this curve? This curve is folium. Okay. This curve. This straight line is x plus y plus a is equal to 0. That is asymptotes. This point is 0 0. And this point is 3a by 2 3a by 2. Okay. See, given curve is x cube y cube minus 3a xy is equal to 0. Then what is the tangent at the origin? Tangent at the origin, this thing equating the lowest coefficient of lowest degree term is equal to 0. What is lowest degree term in x? X to the power 1. What is lowest degree term in y? Y to the power 1. Then after solving this, x equal to 0, y equal to 0. Right? This is the tangent at the origin. Okay. See, tangent at the origin, we got two tangent. One is y-axis and one is x-axis. It means there are two tangent which are real and distinct. Okay. Then this point is node. But we have to verify whether this is node or not. You can verify by the formula also. You have to evaluate fxy whole square, fxx, fyy. Check whether this is greater than 0 at the point 0 0 or not. Right? This 0 0 satisfies this equation. Means this is the node. Next, x to the power 4, y to the power 4, 4a xy is equal to 0. Again, same way. Here are the two tangent, x equal to 0, y equal to 0. Right? Then this is the node or conjugate point. Say, the same way, just like the example 3. This 0 0, you have to evaluate from this equation. That what is fxy what is fx? Fxy whole square, fxx, f of yy, check at point 0 0. If it is greater than 0, then 0 0 is node. Okay, if it is less than 0, if this thing is less than 0, then 0 0 is conjugate point. Okay, this is the conjugate point.